What's up, everyone? It's your boy Young Dev. What's up? What's up? So today's video is a bit different. I think I will be a little bit disturbed because I made some notes. I made some notes for you also that I don't forget these kind of things because they are quite important. So please bear in mind with me if I keep on looking on my screen. But then I'll try by all means not to do that. So in today's episode, we are talking about tools that every developer should know. You gotta know those tools, man. You gotta know those tools. There's so many tools that you can use in this world as a developer, as a software engineer, or as a software architect or whatever. So those are the tools that you can use, right? But then the main question is, why should you use these tools for? I feel like I need to tell you this. The most important thing as a developer you should know is to be able to write high quality code. It's very important. I'll just, Okay, let's get back to it. So in today's episode, tools every developer should use, right? So what we're gonna do today is a bit different, but then we'll be looking at these tools. What are these tools, right? Why you should use these tools? What are they being used for? And the importance of these tools. So the first thing is we'll be looking at integration development environment. That is our IDEs, right? We're looking at our IDEs. So IDEs are things like IntelliJ, Visual Studio Code Editor, something call it Code Editor. So it's IDEs or Code Editor, depending what you're using, right? So IntelliJ, Visual Studio, Eclipse, NetBeans. Do you guys still use NetBeans? I don't know. Vim. I don't know if you still use Vim or people are using Vim. Guys, please bear in mind, every opportunity I get, people are using Vim. I need to throw some jabs on you. Okay, so Vim, what else? PyCharm. There's so many IDEs, right? But then we'll stick to the popular ones, which is Visual Studio Code, IntelliJ, right? And Eclipse, right? They're very powerful tools because now they have those, they help you write and debug code in a way that they provide you with those debugging tools. Also, it helps you with things like code completions, right? They help you with things like code completions, code refactoring, which is going to help you to write a quality code. Because remember, it's very important to try by all means to write high quality code, right? So there are different ways how people define high quality code, right? Some they say you must comment, some they say you must use Pascal case. If you're using those principles or standards, Pascal case, camel case, or snake case, there's even one called snake case. The IDEs, they are very powerful tools, right? Because now they can help you write and debug code and test your code. Because now at some point you'll end up writing unit tests. I'm gonna talk about that. You don't talk about unit tests, don't worry. At some point when I have to write unit tests, you have to debug your code, right? You have to debug your code. At some point, you have to debug your code, right? At some point, you have to write unit tests, you have to write comments and so forth. So these platforms, they're going to help you to write that high quality code, right? They're going to help you to debug. They're going to help you to write those tests. Code editors and IDEs, they are very important in this case because now going to help you write high quality code and debug your code. Number 2, right? Version control system. VCS. Your version control system. So when you're talking about version control systems, we're basically talking about powerful tools like Git. Okay, what is Git? So at some point, you have to manage a high code base. What do I mean by managing high code base? Collaborating with your team, right? Creating branches. Obviously, you're working with your own branch. Create a branch. You make your changes. You commit your changes. That is version control system. That is Git. You commit them. Then you continue working on. You push them. That is still version control system. You keep on working, you push them again, you pull, okay, you fetch, you make a pull request, make a PR, you merge your changes. So those are the tools that are going to help you work, because in most cases, it is very rare, very, very rare that you will be working at a master branch or at a dev branch. It's very, 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 very rare that you'll be working in a master or develop branch. So what happens is that for each task that you'll be doing, create your own branch, and then you do your work, and then you push those changes, and then you create a pull request which is going to match your changes with our dev. Then you're done. So that's the importance of Git. Git is one of the most highly used version control system. Number three is command line interfaces, CLIs. command line interface. I know people when talk about command lines or commands, they think of hacking. No, I'm not talking about hacking and those green screen, the binaries or movies. Now, sometimes I used to watch movies, right? Obviously, I used to enjoy movies back in the days when I was a kid, when I saw all those green screen FBIs, I'm hacking your location, blah, blah, blah. And I always thought like, as a software developer, I'll be having green screens. I'll be hacking. But it turns out I'm not. I'm a software developer, man. I'm a software dev. Creating systems, fixing them, and then crashing them. Okay, yeah, CLI is command lines interface. So there's so many important command lines interfaces that you can use. Things like bash. Remember I talk about git bash for you to write those commands. If you're making changes, if you're committing changes, if you are pulling changes, or if you are pushing your changes, or if you are even matching. Now, some devs, they prefer writing commands. Like if they are making changes on the code or if they are doing anything in that case, they prefer writing command. If there's nothing wrong about that, you can use CMD or you can use PowerShell. I feel like that's where PowerShell comes in. But then one important thing, they help you to navigate in your files, right? As I told you that I only use CMD just to go to file, or PowerShell just to go to files and navigate to my files and directories and paths and so forth. Yeah, so they help you do those things. But then in most cases what we use command lines for, maybe it's like it's essentially for working with servers. Like if you're working with servers, something like this, obviously definitely we have to use command lines and so forth. And also if you're trying to deploy your code, like deploying your code into production, deploying the code into test environment or whatever environment. We want to talk about environments, don't worry. So I feel like that is where command lines interfaces work. So command line interfaces, they're essentially for working with servers and deploying your application to production. So definitely we're going to need to use our CLIs for that. Okay, the next tool is package managers, right? So package managers, they're basically what we use to manage our packages or dependencies in our application, to install them, to remove them, and also to update the version of that package. NPM is a highly used package manager for working with applications for Node, like things like React, React.js, Angular, TypeScript, and so forth. So NPM is for those ones. So, and then PIP. PIP is a package manager for Python. If you're working with Python, if you're trying to install dependencies, or if you're trying to install dependencies and so forth, then PIP is your go-to guy. And then for Java we use Maven. I feel like Maven and Gradle. I feel like Maven is the highly used one, or is the mostly used one, the Maven one, because now it will help you to install those dependencies, because now you're working with a big application, right? You're working with a big application, and there are so many dependencies within your application. There are things like H2 database, there are things like Spring Data, there are things like for testing and so forth. There are so many dependencies. There are things like Oracle drives. So it's just so many dependencies within your application. So one guide to go to is to use Maven to install those dependencies. So Maven is going to help you to install those packages and also to install it. So with C#, it's highly used on a Visual Studio environment. So it's using a Visual Studio environment. You just go to Naked Package Manager and then install those packages, things like EFCOM, things like SQL, or any databases that you'll be working on. So sure. Then the next tool we're going to talk about is continuous integration and continuous deployment, CICD, right? Let me just read this down for you, because I think I wrote a very important notes before you can talk about it, right? So tools like Jenkins and Travis CI are essentially for automating your build, tests, and deployment process, right? With CICD, you can ensure that your code is always in a deployable state and that your changes are tested thoroughly before being deployed in production. Look at this. The most important thing we want to make sure as developers or as the team in a certain project is to make sure that our code is always in a deployable state. There are so many environments in an application or in a system that you can work on, or that exist, right? So in organization, there are so many environments. Let's say, for instance, there's dev, there's test, there's pre-prod, and there's prod, right? Prod is the actual production where everything is live and ongoing, right? So on prod, I'm definitely sure you understand. In prod, you must make sure that everything is working perfectly and 100% as it's supposed to be, because it's production. It's what customers are interacting with, right? We want to make sure that in prod, everything is 100% working. But then before we can even go to prod, there is dev. where we do our development. How does CICD get into play in that? Okay, now remember we said like CICDs, they automate our build and test and deployment process. We want to make sure that every code that we write, the builds are passing, the coverage check is passing, the tests are passing. But then now, if our code is always in a deployable state, then we are good to go. If our builds are automated, if our tests are automated, then we are good to go. Then our deployment process is also automated. We know at this time or in this day, there's deployment happening. We don't have to do manual deployment. No, but we know exactly that, okay, our integration or deployment is automated in this way, then we are good to go. So knowing CICD is very important. The next tool is issue tracking and project management. So issue tracking and project management is quite a very interesting tool to know, because in a team, there are so many people involved. There's devs, there's business analysts, BAs, testers, quality analyst, quality assurance, incident analyst, query analyst, and so forth. There are so many people. And for us to manage our project properly, so that we finish our project or we complete our project in time, we finish our sprints in time, we finish the projects within the budget, we plan the project properly, we need things like project management and issue tracking, guys. Come on, you see? So there are so many tools that there's like Trello, Jira, Asana, Basecamp, and also Azure DevOps, right? So with issue tracking, what is issue tracking? So basically with issue tracking, in a development environment, in a corporate world or in an organization world, what happens is we get to assign the ticket, right? Because remember, there are so many people working in this application. There's so many things that need to be done. There's so many things that needs to be fixed. So we get to assign a task. So a ticket can be a task, a fix, a feature, enhancement, or a hotfix or something like that. So that can be your task, right? So you get to assign that task, and then you have to do that task, right? When you're doing that task is in progress. When you are done with that task, it should be reviewed by certain people, whether BAs or testers or whatsoever. Should be reviewed. Once it's being reviewed, then it should be done, like actually completed and done. We always want to make sure that our workflow is streamlined. We know how we work. We know where we are at this point. We know where we are going, and how is our direction, right? Another tool that I want to talk about is code analysis software, right? So in terms of code analysis software, we have software number one, it's called SonarQube, right? So let me just read this out because I wrote a few notes. So SonarQube is an open source platform for continuous code quality inspection. Code inspection. It supports more than 25 programming languages, and it provides a comprehensive set of code analysis rules. There are certain rules which are provided by SonarQube and say, if these rules are not met, then this code is not of high quality. And then there's number two, it's Coverity. Coverity is a static analysis tool that can help you find and fix security vulnerabilities. It's gonna help you find and fix security vulnerabilities. It supports Java, C#, and C++ programming language. It can be integrated with popular IDEs. It can also be used to analyze code on local machine or as part of CICD pipeline. I feel like that's also one important thing as to why you should use these tools for code analysis, right? Because they help you write high quality code, man. And also the last one is ESLint. So ESLint is a popular JavaScript linter that can help you enforce coding standards and identify potential issues in your code. Most of these analysis tools, they help you identify issues in your code, right? Okay, then the next tool that you should know is testing frameworks, right? So in software development, testing is very, very essential. Writing, you remember when I spoke about writing test? Writing test is very essential. It's either unit test, integration test, and so forth. It's very essential because we're trying to say, okay, fine, you've done the development. This is how it's supposed to behave. Does it behave this way? And if it does, then the test pass. So if you can use these testing frameworks to make sure that you test your code in development before production, so that in your pipeline, these tests can pass, then you are enforcing high quality code and well-tested code, because you want to make sure that the code is thoroughly tested before it can go to production, right? There's so many testing frameworks that you can use depending with the language, right? So test framework number one is JUnit. JUnit is a popular testing framework for Java application. It provides a simple and easy to use testing framework. It allows developers to write unit tests quickly and easily. Come on. We have CICD. We have code analysis tools. Everything is passing. Everything is green. That was the problem. That was the problem. Then we are good to go. We are happy as dev. Because the funny part about being a dev, the nice part about being a dev is when those tests are passing. If whatever you're working on, it passes, the pipeline is passing, because it's very, very painful when the tests are not passing the pipeline. It's very painful. Trust me, I know it. But then if your tests are running in pipeline, your code is of high standard, then we're good to go. The code is in a deployable state, we are good to go. Who are we to judge? Come on now. Then the second one is Selenium. So Selenium is a popular testing framework for web applications, right? It allows developers to automate web browser interactions and also test web applications across multiple browsers and platforms. It provides supports for both functional and regression testing, right? Also, it allows developers to write tests in various programming languages. So it's very important to understand those testing framework, because now we try to make sure that our quality is of high standard and it's well tested and it's deployable and it's tester passing, guys. Come on. So now with these tools we'll be speaking about, all of them, right? I told you about almost 10, if not, almost 10 of them, right? So now the question is, how do you actually, because now the main thing, they help you collaborate. Let me come closer for this. These tools, they help you collaborate with your team. They help you write high quality code. They help you enhance your productivity. Come on, guys. Are you telling me that's not what you're looking for? For instance, you're a Java developer, IDE, IntelliJ, a command line interface, PowerShell, or CMD, or whatever, or Bash, or whatever. Version control, Bitbucket, or GitHub, or GitLab. Issue tracking and project management, Jira, Azure DevOps, Trello, Asana, is there. Okay, CICD, Jenkins, it's there. Testing frameworks, it's there. JUnit. Code analysis tool is there, SonarQube. I'm like, what? So those are the tools, those are basically tools that every developer should know. Because there are more of these tools, right? There are more of these tools, and there are so many of these tools, and then they want to help you write quality code, collaborate with your team in a very beautiful and nice way. So if there are any tools that I missed, drop them in a comment. If you like this video, please make sure you comment out and say nice one, and also drop a like and then share this video. Then also don't forget to subscribe. It's Young Dev. It's all about software engineering, software development, quality code.